In our first video review, we'll be focusing on limits of a function. Now, here in front of us, we have a pretty simple limit of a function equation where x approaches k. Now, unfortunately, the value for k is not yet disclosed. To find our variable k for this equation, we have to use this piecewise function. Now, for this function to be fully continuous, we have to find the value for k, so this function will not have any holes, breaks, but most importantly, our left side limit of this function as x approaches 4 from the left side will equal our right side limit as x approaches 4 from the right side. Now, our right side of this equation is anything below 4. So, as we can see, this is our equation for everything below 4. So, as our limit approaches 4 from the left side, it's x squared minus 3x. And that would have to equal our limit of x approaching 4 from the right side, which is our variable k plus x. Now that we have our equation perfectly set up, we can just plug in our value and get a full equation and try to solve for x. So it would be 4 squared minus 3 times 4 equals our variable k plus 4. Now this simplifies down into k equals 0. Now that we have our value for k, which is 0, we can cross out this variable and plug in a 0. Now unfortunately we can't just plug in a 0 straight into our equation because you cannot divide anything by 0. In this scenario we have a square root at the top, so we can rationalize the numerator. To do that, we have to rewrite the equation of x, in this case approaching 0, of square root x squared plus 9 minus 3 divided by x squared, and multiply it by its conjugate, which would be square root x squared plus 9. Remember to flip the sign, plus 3. And what you have to do to the numerator, you have to multiply it the same by the denominator. So it's the same as multiplying by 1. 9 plus 3. Now, once you multiply these two equations together, you get limit as x approaches 0 is equal to, the square roots here cancel out, so just be x squared plus 9, and then negative 3 times positive 3, that's negative 9, over x squared times square root x squared plus 9 plus 3. Now, we still cannot plug in the 0, as if we plug it in, it will be 0 here, which make the whole denominator 0. Fortunately, we have x squared in the numerator and x squared in the denominator, which we can just cross out, leaving us with limit of x approaching 0 of 1 plus 9 minus 9 over square root x squared plus 9 plus 3. Now, in this scenario, there's nothing stopping us from plugging in this 0 into this equation. And once we plug it in and simplify down the whole equation, our limit as x approaches 0, or k, is 1 over 6.